here in this case, we are interested in the calculation of current in 10 ohm resistance. This is 10 ohm resistance. First step is remove the load resistance and redraw the same circuit. Do it fast. Removing RL and redrawing. Same circuit. In this case, the circuit will be something like this. This is A, this is B. This is VOC or VTH. This voltage. This is 3 ohm. This is current source, which is 10 into IA, is already defined. This is 1 ampere. This is 2 ohm. This is 16 volt. And this current is the IA. Now look at it. When this load resistance is present, this current is IA and this is 10 IA. I will name some it's different, IA1 and IA1 when it is open. Is it right? Now our aim is the calculation of VOC. Means for the calculation of VOC, we have to calculate current in this branch. Which method we will use? There are multiple methods. I will discuss the two and I will select the one. We can use the mesh analysis. In that case, this is I1, this current may be the I2. But in this case, we have very limitation. We cannot use the mesh analysis because we are not in a position to apply the KVL here, this loop, this current source. And we cannot apply the KVL to this bigger loop also because here is the current source. Means we have only one choice, and that choice is the nodal analysis. This current is IA1, is it right? I will name this current as IA1. This current is, I will name it as IX. This current, I will name it as IY. Something name I have to give, that's why I give something name. This is IA1, this is IX, this is IY, or you can do any name of your choice. Now apply the KVL, because हम KVL use नहीं कर सकते. If we are using this KVL, this is the problem, and if we are using this bigger, this is the problem. That's why we have to use the nodal analysis of KCL. Means applying KCL at node A. If we are applying the KCL at node A, how is the equation? This is incoming, this is incoming, this is outgoing. Means equation will be IA1 plus IX, which is equal to IY. Use any names for the current. This current IA1 0 plus 16 minus VA. The 16 minus VA divided by resistance of this part, which is 2, plus IX, this current, which is 1 ampere, which is equal to IY, current in this branch. How much is the equation for current in this branch? I will come back to you. How much? What is the equation? Saurabh.
Hello.
What is the equation for IY?
10I.
Rishikesh. What is the equation for IY? Rohan. Ruchira. What is the equation for IY? Can anyone have any clue? Chaya. Okay, I will come back to you. Now look at carefully. In this case, this is current source. इसके सीरीज में कुछ भी हो, इसका वैल्यू कितना रहेगा? इट्स वैल्यू इज द सेम एज द वैल्यू ऑफ द करंट सोर्स। आर यू गेटिंग मी? सपोज इफ वी हैव दिस इज 10 amperes और इसके रजिस्टर सीरीज में कितने भी रेजिस्टेंस हो, this may be the 1000 ohm or this may be the 5000 ohm or whatever. How much is the current in this branch? इस branch में current कितना रहेगा? It is always the value of the current source, which is 10 amperes. Is it right? Be careful over this point. Now here in this case, this current source is of the 10 IA. That's why independent of these resistances connected in series with the source, क्योंकि हम टाइम बिंग के लिए क्या assume कर रहे हैं? ये टर्मिनल नहीं है. We are assuming this A terminal is not existing because it is open circuit. This part is not existing because it is open circuit. That's why this is one branch. इसके series में 3 है. Even though its current source का value होगा, it is 10 into IA1 is this value. इसको ध्यान में रखना है सभी लोगों को. This is new point, typical point. Is it right? Now simplify this equation. If we are simplifying this equation, it is 16 divided by 2. It is minus VA divided by 2 plus 1, which is equal to 10 into IA1. If I am shifting this value to the next side, then VA by 2 means it is 0.5 VA plus 10 IA1, which is equal to 16 by 2 is 8 plus 1 means 9. This is 9. This is equation number 1. Check it out, equation number 1. इक्वेशन नंबर 1 को आपको चेक करना है. Yes, I guess it is correct. If we have one equation, how many unknowns we have here? VA and IA1. Now find out the relation between VA and IA1. What is the relation between VA and IA1? Already we have calculated this relationship. Means find out IA1 in terms of VA or VA in terms of IA1. Already we have this relation. IA1 is equal to 16 minus VA divided by 2. But we know. This we know. If we are simplifying this, 2 into IA1, which is equal to 16 minus VA. If we are shifting this VA on the left hand side, then its value is a VA plus 2IA1, which is equal to 16. This is the equation number 2. Is it right? Now we have the two equations and the two unknowns. Unknowns are VA and unknown is the IA. We have the two unknowns. VA, that is voltage at node A, and IA, the current in this branch. Calculate these values. दो इक्वेशन है, दो unknowns है. Find out its value. Yes, do it fast, little fast. Yes, anyone? Yes, can anyone? Yes, Rishikesh.
Sir, VA 15.77
Yes.
and IA 0.11.
0.11 amperes. अविनाश, correct है? अविनाश.
Yes, sir.
Correct. Saurabh.
Correct.
Correct. Now, if we know this value, now find out the VTH, because we are interested in this VTH. Means we have to find out this IY. First, I will find out the IY. Now, IY is equal. What is the equation for IY? 10 into IA1. This IY is equal to 10 into IA1, which is equal to 10 into 0.11. How much is the value?
0.1.
1.1, I guess.
Yes.
1.1 amperes. Is it right? Into 10, 11 into 10, or 0.1 into 10. Sorry, 10 into 0.11. How much is the value? I guess it is 1.1 ampere. If we know the IY, then find out the VTH, which is equal to modulus value. We are traveling from the B towards A. Here downward current, here plus, here minus. We are traveling from the B towards A. If we are traveling from negative to positive, which is a plus, its resistance is a 3 and current is 1.1 ampere, which is nothing but 3 into 1.1. This is 3 into 1.1. This is 3.3. Is it right? 3.3 volt is the value of VTH. Is it right? If we know the value of the VTH, then next we can find out the value of RTH. But for the calculation of RTH, what we have to do? We have to replace this resistance by its short circuit. Now look at how will be the figure for the calculation of RTH. Now look at how will be the figure for the calculation of RTH. I will draw that figure somewhere here. I will not write the wording. I will write here RTH calculation. How is the RTH calculation? Its formula for this case is RTH is equal to VOC upon ISC, and we are interested in the calculation of ISC, short circuit current. In this case, the figure will be something like this. I will complete this little faster. Here is the current source. Is it right? This is the source, and here is the terminal A. This is B. We will short circuit it. And this current I will call it as ISC. This is 3 ohm. This is current, which is 10 IA1. In this case, I will name it as IA2. 10 IA2. Because current in this branch, I am naming it as IA2. Is it right? This current is 1 ampere. Is it right? Now look at carefully. This is 16 volt. 16 volt. This is 2 ohm. Is it right? 16 volt, 2 ohm. Now little careful. This short circuit is parallel to this 3 ohm. And whenever this short circuit is parallel to any one, then its parallel combination is always 0. Or current in this path is 0. First find out its equivalent circuit. Otherwise, this will be the node 1, this will be the node 2, this current source is connected. Then it becomes complicated. But simple philosophy is that ये जब दोनों पैरेलल होंगे तो इस ब्रांच में कितना करंट आएगा, जितना यहाँ से जो भी करंट आएगा ये कंप्लीट करंट इसी ब्रांच में जाएगा. This how will be that equivalent circuit, that is to be mentioned here. Now here its equivalent circuit will be something like this. Here is the current source. This is another current source, and its parallel combination. Its parallel combination is the short circuit. Its parallel combination is the short circuit. This is point A. This is point B. Its parallel combination. This value is 10 into I2. This is 10 into I2. Sorry, IA2. 10 into IA2 because this current is the IA2. This is 16 volt. This is 1 ampere. Is it right? Again, we will use the similar principle here. Suppose I will name this node as a B in this case. Is it right? This current I will name it as IP, and this current I will name it as ISC. That is short circuit current. Is it right? Now, if we are applying the KCL at node B, if we are applying the KCL at node B, how is the equation? This IA2, sorry, I have forget to draw this resistance 2 ohm. There it is, the 2 ohm. Is it right? If we are applying the KCL at node B, incoming current is equal to outgoing current. Means equation will be IA2 plus 1 ampere is equal to ISC. Is it right? If we are simplifying, how much is this current? This current will be, that is a 0 minus 16 minus VB. Means 60 minus VB divided by resistance of this path, which is 2, plus this current. This current is IP. Is it right? This is IP. And how much is the value of IP? 1 ampere, which is equal to current in this branch, which is 10 IA2. And we are interested in this 10 IA2 or ISC. In this case, if we are simplifying this equation, it will be 16 divided by 2 minus it is VB divided by 2 plus 1 is equal to it is 10 into IA2. That is the equation. If we are simplifying this equation, this VB2 I will shift on the next side, means it is 16 divided by 2 plus 1, which is equal to VB divided by 2 plus it is 10 into IA2. This its equation will be, this is 0.5 VB plus 10 IA2, which is equal to 8 plus 1, that is 9, and this is the equation number 3, I guess. Again, we want the relation between IA2 and this VB. This is IA2 and VB. This relation already we have with us here. Look at this. That's why we know what we know here. Already we know that is IA2. This IA2 is equal to 16 minus VB divided by 2. This, if I am shifting this value, is 2 into IA2, which is equal to 16 minus VB, or this VB we are shifting on the left hand side, then VB minus 2IA2, which is equal to 16. This is the equation number 4. Solve the equation number 3 and 4. Solve the equation number 3 and 4. Calculate the value of VB and IA2. Find out these values fastly. If we know VB and IA2, in what value we are interested? ISC. We are interested in the ISC, that is short circuit current. What is the short circuit current? 10 into IA2, which it is 10 into IA2 will be that value. And if we know this, then we can find out its value of the RTH, which is Thevenin's equivalent voltage, which is VOC upon ISC. How much is this calculation? Can anyone have this calculation? Yes. Anyone? Okay, fine. I guess you can do the remaining part of this particular problem because I have taken you to the comfort level. Now, you can find out this VB, you can find out this IA2. By knowing this, you can find out the ISC, you can find out the RTH. You know the procedure. When VTH and RTH is known, then complicated network is replaced by Thevenin's equivalent network, and you are able to find out the current in the required branch, which is the current in this 10 ohm resistance. Yes, Shailesh. Yes.
0.8.
Which is?
VB is 16.18.
16.18. IA2?
IA2 is 0.09.
0.09 amperes. This is 10 into 0.09 amperes. How much is this value? 10 into 0.09. 0.9 amperes. This is 0.9 amperes. Right. That's right. Then you can work out this remaining problem.